another aspect to this is dividing disease into three types of disease. And I don't know if it's a common idea in medicine, because I'm not trained in medicine. I'm trained as a marine biologist. But dividing diseases from chronic disease versus diseases of clear defect versus diseases from the outside. And by that, I mean infectious type disease or injury. Medicine has done really well with diseases from the outside, pathogens, et cetera. Not in all cases, but in most cases. And has done making headway for juvenile diseases, diseases of defect, where you have a mutation. And most of those express themselves early in life. The Alzheimer ones express themselves at least in midlife when you have the mutations. But those are clearly things of defect, and I suspect that genetic manipulation will have benefit across the board with time and refinement. The last piece, which is the more important in terms of public health, diseases of aging, whether it be cancer, Alzheimer's disease, heart disease, we've only made headway in a few of them. For example, cancer survival rates have not really improved for most cancers, not all. Some we've made tremendous headway, and I suspect that many of those relate to cancers related to clear defects. But in the case of Alzheimer's disease or other neurological diseases, they're chronic conditions. People develop them and they don't immediately die that day. The neurons don't die that day either. They continue to function on at some level. And we really barely understand that. And understanding that's essential. So whether you can do gene therapy, I mean, of course, people have done gene therapy in cell models, and you can say that people have done gene therapy in transgenic models. But in humans, we're not anywhere near that. And not even for the mutations. To my knowledge, no one has proposed gene therapy there where it actually has a good chance of success.